Well, I'm very grateful for you having me here, and I'm grateful for seeing so many people interested in civic tech and hopefully also in census and related data that I would like to talk about today. So I'm going to try and keep it a little bit short. I have slides which I'm going to share on the screen and which are also available online. If you want to follow at your own pace, I'll put that in the chat if I can figure out how to do that. Oh, my chat window disappeared. Ah. Okay, maybe I'll share it afterwards, unless one of the organizers wants to put it in. I lost my chat window. Sorry. So I can't hear anything from the room. So I'm hoping that if any of you have comments, I don't mind being interrupted in the middle, or we can have more questions at the end. So what I want to talk about is give a brief overview over data that we can use in our everyday lives. Statistics Canada does a pretty good job of collecting data. Our census data is excellent. There's lots of other great data series we have. And I want to just start this off in a light way by exploring CensusMapper. So this is a platform I built, I think, 9 years ago, and it is somewhat out of date in a sense that the technology behind it is a bit rugged and old, and I hope you forgive me for that. I just haven't found really time to update. And what I want to show you is what CensusMapper sort of is. What it does is it takes census data. So right now it hosts the censuses from 1996 up to 2021. Basically the census profile data at all levels of geography. And it allows the mapping of this data fairly flexibly. And so what you, for example, see here is a map that I'm going to move this over to Toronto. So we can see it here. So this is a map that shows net migration. So what it does is actually it combines under the hood two censuses, 2011 and 2021, and does some adjustments to the geography so that this works. And what you see here is, maybe I'm going to zoom in a bit, is it takes the number of children or number of people in each of these age groups that you can see here. So the under 5-year-olds in 2011. And it looks how many of them are still around in 2016. Well, in 2016, these kids are going to be 5 to 9 years old. So I can compare them to the 5 to 9 years old in 2016 and look if on net, how many of them have left a region or come to a region. And what you see here, that kids that maybe get born in the central parts and live there for the first couple of years of their life, 5 years later, a lot of them move out to further outlying regions. So we can walk kind of through the ages here. And you see still a bit of effect like this for 5 to 9-year-olds. But once they get 10 to 14, so those people are going to be 15 to 19 by the time the 2016 census rolled around, and you can start to see them come into like University of Toronto area, and then of course at these ages streaming into the central parts of the city. And this is something that we can continue here by going forward. So the 20 to 24-year-olds still come into the city. By the time they reach the ages 25 to 29, or 5 years later, they're going to be 30 to 34. They're starting to leave the central areas again. So these might be university students leaving again, or these are the parents of those kids that we saw leaving. And so the cycle begins again. So what we see here is really the generational pulse of the city. And CensusMapper generally, it allows us to, there's a whole bunch of pre-made maps that we can look in that people have made. So anybody can actually make maps on CensusMapper. Say I want to look at Visible Minority Explorer. So here, let's move back over to Toronto again. So here we are looking at different visible minority groups. And we can look at, say, where do South Asian people live on average, more or fewer or more of them. So they tend to live in these suburbs here, Chinese in these areas. So we can see different aspects of our city fairly easily. So this is based on the 2021 census. If we want a finer view on this, we can zoom in and get it at dissemination area geographies, or we could zoom out and view it at more at the city level, for example, compare different cities to one another. So that is CensusMapper. Now, maps are great, but often really what we want is we actually want data. And we want to think about how we can get this data and work with it. So there's an API server on the back of this, where we can, for example, go and we might be interested in things like, just as an example, look at adjusted family income deciles. It's a great metric that StatCan offers that allows us to understand to what extent do people, or in which income decile do people live? How do they experience things? So adjusted here simply means that what they do is they take the income of a family unit and scale it by some scaling factor depending on the number of people in a family to effectively say, well, how rich does it feel if for this person to live in a family? There's some synergies. I mean, if you're a couple household, you might not need twice as much income to feel as rich as a single person. So it's StatCan thinks it's roughly a factor of 1.4. And so what this does is it gives us a people-based metric of income. And what I can do here is, for example, just start selecting these income metrics and collect them up. I'm just going to grab a couple here of the bottom couple deciles. I can select the region that I'm interested in, for example, Metro Toronto, or maybe that's too ambitious. I just want the city of Toronto. I'm selecting here the city of Toronto. And then I can go and I'm saying I want this at maybe the census tract geography level data. And I can now, actually I would have to log in to do this. It's free to create an account. I can grab the data, or for the purposes of our talk, what I can also do is grab the R code that actually gives that data in R, where I can use it as a statistical programming language that you may be familiar with, where I can use it to analyze data. And this is what we're going to do. So we're basically going to grab the code that's here and start working with it. But before we do this, maybe I should say there's a bunch of R packages that I've written and I'm maintaining that help us ingest census data and other StatCan data and data around from CMHC or the Bank of Canada that allow us to work with data in a reproducible and transparent way. So let's do this here. Here on the left, what we see is the code that is required to do what you see on the right as output. So what I'm grabbing here is all the internal vectors from the income deciles that I've just shown you from CensusMapper, and I grape the data from the 2021 census for the region of Toronto. This is the region code. If we look, remember back where I selected the region, the StatCan region thing. Here's the vectors that we're interested in at the census tract level. And I want the geographies for that. I do some, the rest of this is not really that important. What I do here is just simply rotate Toronto a little bit to make it look nicer on a map. And then I group my data because 10 deciles is a lot of information. I group it into the bottom 3, middle 4, and top 3 deciles. What we're interested in then is here is when we are looking at something like what's the geography of income, we want to allow for income mixing. So there could be high income people living right next to low income people. If we average them, it looks like a median income neighborhood, but there's actually nobody of median income, of middle income. But what this does here is what it's trying to do is a 3-color kind of key that you see on the bottom. So basically a census tract that's 100% lower income people in the bottom third would be of this orange color that would sit right at this corner. If they're really almost all people at the top of your income distribution, there'd be pink here. And if they're in the middle of the income distribution, the middle 4, they're up here. So If we're looking at the 50% line here, this is the line where 50% of the people would be in the middle 4 income brackets. And we see there's actually really no census tract in Toronto that has people of this type. There is no middle income census tract or census tract that's dominated by middle income people. So really what we're doing here is, just to go back to the program, this is just generating this tricolor map that divides this into different color groups, and then we just map it by plotting it. And that's really all there is to it. So we see, if you're in Toronto, you're probably familiar with this. High income area here in pink are showing up, and these two basically pockets and a little bit along the waterfront here. Then we have lower income. There's a couple of parts in here that I get into the orangish tones. And then there's the greenish parts, which is sort of a mixture between middle and lower income, and the gray, which indicate really good mixing of all 3 income groups in a census tract level. The reason why I show this is because you could tell very simple and compelling stories, learn something about your city with just a little bit of code. And what I really like about this, in a very reproducible way, you can basically take this, copy this over, paste this into your own R code, and you can write it and you can run it. You'll have to, I'll link to this where you can do some convenience functions that I have here, like aligning Toronto and adding this nice little legend that tells us the distribution of where each dot here is a census tract, and it tells us where they lie on average. Well, that's for census data. And we can do other things with this. Of course, we can also just grab the data and look at more longitudinal data over time. I'm not sure if you've seen these maps here. I'm going to leave that for you to explore, that give like a 3D view of population change over time. And it's in the slides that will, I think, be shared or in the chat, and you can explore. But there are other data that come from StatsCan that are great for understanding how things work. So here I just want to look, since we're with the theme of income, I want to look at income again, take a long look at income time series. That is in particular from this table number 11100239. This is how the different StatCan data series that are grouped together in tables are identified. And we can grab this data, for example, and look for here the total income. We're looking at the median for 25 to 54-year-olds. So that's the prime working age population. And this basically just imports this data that we then can plot. And here I'm labeling it sort of at the end by which metro area we're looking at. And it shows you trends over time. So what we see here is Toronto, for example, in pink, used to be fairly medium high income area up until sometime in the 2000s when it started dropping. And by now, Montreal and Vancouver have overtaken Toronto when it comes to median incomes. Ottawa and Calgary fare still a lot better. Calgary did lose quite a bit with the oil shock, but it's still holding up quite well. And Ottawa generally has been starting to get really high, starting also the 2000s. One thing I should say here is that the income time series and the sources has changed over this time span. So there's some inconsistencies. And if one really wants to go back pre-2000, one should probably do a little bit more work to know that we're not, that we really know what we're talking about here. So this is the cansim package, and another way to import and work with StatCan data in a reproducible way. Again, you can just really grab this code here, paste it into your R console and run it, and you'll get these graphs. What this also, of course, allows you is to play with it if you're interested in average income, if you're interested in just income of females, or say a different age group. You can easily modify this code and highlight it. Or if you want to look at a different metro area that you want to throw into the mix. So it's very adaptable this way too. Another thing I want to stress is that these packages play well with one another. I can, for example, grab data from CMHC and then here about census tract level housing completions. So this is looking at housing completions by census tracts for the year 2023. And what I'm going to do here simply is grab the geographic data for this from the cancensus package and join the completions data on. Here I'm just setting up some intervals to make some nice little scale here to break it up a bit and graph it. And that's it. And we can see where construction activity has been or hasn't been in Toronto. Again, you can just copy this code, paste it over into your console, and it runs right through if you're interested in, say, a different year or in a different city. You can see here the StatCan geographic code that we used for Toronto that shows up in both the CMHC call and also the census call. We can just switch that out with something else and get the same thing for a different city in the country. CMHC's coverage, of course, is not perfect. They concentrate on metro areas, but it's something that's fairly easy to do. What I really want to stress here is that data is up to interpretation. So different people look at data and come away with very different stories. Also, different people pick different data they're looking at. Just the choice of what to look at and what to investigate really depends on people's interest. And that's okay. It's actually good. And that's why I hope that more and more people will start to actually look into this, build reproducible data, share it, their analysis, and bring their own perspective into this. One thing I'd like people to keep in mind is to often just sit back and try to understand what is the data generation process. Like, where does this data come from? How is it generated? What are maybe causal structures in our data? And what are things that maybe we don't want, relationships in the data that are not that important? And let that guide how you look at data. I do have a book project that tries to give an overview similar to what I've shown here, but in more depth about how to use these packages to really analyze Canadian data. And I'm hoping to build a community, or that this helps to build a community of data users that share code and that we can piggyback off one another in analysis. We don't have to reinvent the wheel every time, but we can look at what somebody else did and saying, oh, that's great, but I want to make slightly different assumptions. So you take their code, make some changes, and hopefully just improve the depth or the rigor of analysis and our knowledge about Canada and how things work here will grow. And that is it for my talk. The slides are online. The source code also is on GitHub that has all the code to run these images. Also, the helper functions are in there, so you can grab that if you're interested. And some links to some blog posts and other resources that have similar ideas that I've just discussed in here. It's a bit weird to give a talk without seeing any feedback from anyone. I hope people got something out of it.
Awesome. Thank you so much. Yes. We have time for about 10 minutes of Q&A. So for those of you online, if you can put a Q or any other letter in the chat to line up for questions, and then we'll pick a few from in the room as well too. Maybe we'll go online first if there's anyone eager to ask a question.
Not immediately, Sam. Maybe take a couple in the room and we'll see if the online queue populates.
Perfect. We'll go Ben.
Hi, thank you, Jens. I was curious, if you were to remake CensusMapper today, what would be your preferred solution to the problem that, like, in a sparse area where very few people live, it looks big on the map, even though not a lot of people live there, if that makes sense. The sort of like land isn't people problem. what would your preferred solution be?
Yeah, so that's a good question. So actually, maybe I should share again my screen here. Let's see if I can get that up, and I can maybe show you what I think this might look like. Where's my link to CensusMapper? So I've played with this idea, and let's see if I have this. Not in any of the public maps. Okay. Oh, here we go. Basically, instead of coloring, just make something like a dot density type map, which is very tricky in a sense if we want to do this at if we want to do this consistently in an online setting and have a multi-color dot density map. But if we see here, if I zoom in, it'll sort of readjust a bit of where it places these dots. So what this is looking at here is, maybe I'll go over to Toronto. That is more familiar to people. So this is looking at where do people with different, where do recent immigrants locate? So people who've immigrated in the 5 years prior to and for this map, the 2016 census. So you can see in red, people from China, in blue, people from the Philippines, and you can see clear sort of geographic patterns. And you can also see, if we zoom out, that so we have India here, or in some pockets over there. I'm sure you're aware of these things. And if we zoom out, we see there, this is not great, but at least at this level, we can see that these sparsely populated areas have only few dots. An issue here is, of course, the dot placement. If I had to redo CensusMapper, I have some ideas of how to have better dot placements at all zoom levels. You'll see for this one here, if I zoom out, it gets blocky because I'm really just placing them randomly in each city census subdivision here, which is not useful.
So cool. I saw a question online come up.
Okay. Can you hear me okay?
Mhm.
Yep.
Okay. So I had a question around the data sources and like it just if you could talk a little bit about like the StatsCan data you use for the census, and then especially like if any kind of like processing or transformations are really needed. So yeah, just which StatsCan products you're using and any high level discussion around what kind of work you have to do to make it useful.
Yeah. So for the census data, so census data became only publicly and openly available with an open data license, I think in 2012. So it's fairly recent that it's actually available. And when I started out looking at this, which was like 2014, 2015, it was actually really hard to get useful census data. It was sort of available, but very hard to work with, which then sort of I got annoyed by that. And then I built CensusMapper as sort of my solution to that. And what it entails really is just grabbing the standard census profile data that's readily available, grabbing the geographic data, and moving that onto my own server, where then I can have an API to usefully access it either for mapping, and what I added a little data later, then also just for pure data extraction for analysis, which then the cancensus package piggybacks off. So by now, StatCan also has APIs for census data. They're not very useful, unfortunately, but they're also available through the cancensus package. You can also get data directly from StatCan that way. It is the same data, so there's really no difference in that way. The only processing that goes into it on my end is for the geographic data, where I might enhance it or refine it for certain purposes. So say cut out water areas more closely than the standard StatCan area does. At different zoom levels, I might start cutting out lakes out of the data. So that's something that is additional processing. Well, one other important part is adding metadata to the variables so that certain other aspects that I haven't really talked much about here work. And the metadata means that if I have, say, an average, I want to know it's an average of what? It's based on what kind of base variable? Or what are the units that I want to associate it with? So this is something that I need for mapping to make it useful, to can automatically select the right units when I map variables. But it's also something important for analysis that allows me to automate certain tasks. For example, I alluded a little bit to it. So census geographies change over time. And often if we want to view how data changes over time at fine geographies, that provides a challenge, right? So the census tract in 1 year might split, or it might actually do funky things. So it might not just split. So even if the geographic identifier stays the same, the actual geographic region might change. And so there's another one of these packages have, because it's a common problem, tongfen, it's called, that automates this process of basically taking two census geographies, say the census tracts on different years, and then does a little puzzle game of how do they fit together so that you have a common geography, maybe by joining some of them for the census years, and then it re-aggregates the data to these new geographies, and it's suddenly comparable in that sense. So that's something, though, that is not done in CensusMapper, but it's under the hood in some of those packages. So you can ask it to saying, hey, give me median income on a geography based on census tracts. It might be a little bit coarser, and give it to me for 3 different census years. And it does that for you, if that makes sense.
Okay, cool. Very cool. Thank you.
Cool. I think we have time for one more question. Is there anyone in the room? Sure.
Thanks for your talk. I just kind of curious, like, how do you begin a new map or project? Do you begin with a question and then try to find data to like solve your problem, or do you begin by browsing the data and try to find what might be interesting to solve?
Yeah, that's a good question. I mean, ideally, I try to go from a question that I have and then try to see if I can find data that's appropriate to answer that question, which may lead to a dead end. We don't have data on everything that can answer any question, but that's typically how I go about. At the same time, I do monitor and check sort of the data that comes through in Canada, especially through StatCan, but also through other sources to see what becomes available, and that might spark an idea, might spark a question that is interesting and related. So you can't completely separate the two, but I do think it's important to have a clear question before starting to work on something.
Awesome. I think we have time for one more if there's one online.
No more online questions. Maybe
Cool.
one in the
If
room.
I can squeeze in a question. I'm really curious, as someone who has not dove into this world of mapping out census data or like any of the technical side of things, it looks so impressive when it comes out, but how difficult would you say it would be for someone who's unfamiliar to dig in for themselves?
Well, so one thing that you can do on CensusMapper is, I think, even if you don't create an account, you can just go in and there's a little button that says new map, or you can have a new map based on 2021 data or on 2016 data. And you can kind of map any census variable that you're interested in just right then and there. If you have an account, you can save it and put some comments on it. CensusMapper typically has a bit of a context on the sidebar to give people context and ground them on what this map is about. The same data can tell different stories. So that's your opportunity to tell a story that you see in the data, or that you can guide somebody. And so that's something that allows you to explore and see your neighborhood in different ways. And that's very simple. In theory, CensusMapper can more complex maps. I've showed off one of them, but I haven't spent the time to have a user interface to make this sort of accessible to people who don't know how it works. And I'm inherently lazy, so I haven't done that work. But it's on my list at some point, but it's been on my list for 9 years, so I'm not sure what that means. But then, of course, there's the option to follow some of the code that other people have done. I've shown off some in the in this talk. So if you're comfortable with coding a little bit, you can go a lot deeper and make maps and analysis that are more interesting, but you can slowly feel your way into this.